Most of us talk about forgetting all the time. In reality, in many cases, we don't truly forget that information. It's there in our brains and we just cannot retrieve it. So basically, we think that memory is very different from search. And RAG is kind of sort of ingrained in this notion of searching for information. And what we're building is a system that works like human memory, where you don't need to search information. We call it omniscient AI, basically. So the AI knows what you need. So if we could have access to infinite memory, we would essentially render prompting and searching obsolete.
Hello everyone and welcome to a new episode of AI Without Borders. I'm thrilled to have Gabriel Kreiman. Gabriel is the co-founder of Memorious, a startup looking to augment human cognition using AI. He was previously a professor for 18 years at Harvard Medical School, but most importantly for this podcast, Gabriel is originally from Argentina. Gabriel, welcome. It's great to have you here.
It's great to be here. Thank you for the opportunity to do this.
So you did a postdoc in computational neuroscience and AI back in 22. What sparked your interest in the field back then, and how was your journey from Argentina all the way to MIT?
Okay, so starting with the journey, I finished my undergrad in Argentina, and then I did a PhD at Caltech in California, also in computational neuroscience. I had a very quantitative background, but I knew I wanted to investigate questions about intelligence, both in biological systems as well as in artificial systems. And that interest was sparked during my PhD at Caltech, a pretty magical moment for my education. From there, I moved to MIT. I worked with Tommaso Poggio, who's one of the founding fathers of very exciting because there was this momentum in the field, this realization that there was a synergism between ideas in neuroscience and AI. And I've continued to think about these problems ever since.
Oh, that's very exciting. And after 18 years as a professor, you're now leaving now to start a new company, Memorious. For people who are maybe not familiar, what is Memorious and what got you so excited to leave your teaching and research role after such a long time?
Well, these are very exciting times for AI in general. I think that there's a tremendous opportunity to make a positive impact in the world through AI. And memory is the basic fabric of who we are. And so we want to build a system that will augment human cognition to build Homo sapiens 2.0, so to speak. So imagine that you can have access to every conversation you've ever had, every person you've met, every book you've read, every email you've written. So all of that instantaneously accessible. So our vision is to endow humans with perfect and infinite memory. OpenAI basically conquered language, and that has changed the world already in the last couple of years. We want to do the same thing for memory.
So you have studied human memory for years. What's your current working model for how episodic memories are formed, stored, and retrieved?
Right. So episodic memories are the basic fabric of remembering who we are, what we did, why, and when. So the basic idea is that we're continuously bombarded with huge amounts of information, and only a tiny fraction of that is remembered. And that is because we end up compressing information in a major way, such that we only retain aspects of our daily lives that are emotionally relevant, that we consciously process, and we discard a lot of the remaining information, basically. So memories are fallible, they are compressed, they're kind of short narratives of the events that transpire in our lives.
I know there's been a lot of progress in the understanding of the field, how human memory works, but what are still some of the biggest open unknowns on how human memory works?
Well, especially in terms of neuroscience, we still have a very long way to go. What are the mechanisms that dictate which memories are stored and which ones are not? Where in the brain those memories are stored and how? Even a very simple question like remembering my name, for example, we don't know where, how, which neurons store that sort of information. So in one day in the future, we may be able to go inside the brain and sort of extract information and extract memories from people, or maybe even help people with memory deficits by using electrodes to essentially enhance memory formation. But we're extremely far from all of that. All of that is still the realm of science fiction.
And this may be a bit of an unfair question, but if you have to rank from 0 to 100, being 100, we fully understand how memory works, and 0 is have no idea, how would you rank our current understanding of memory?
So in terms of neuroscience, I would say 5%. I think there's still a very long way to go. That said, for practical purposes, in terms of the basic cognitive science of memory, I think that we understand well enough that we can build artificial systems that can be transformative in our daily lives. So even if we don't know exactly which neurons are where and when in our brains represent that information, we can build artificial systems that can help us store and, importantly, retrieve all of that kind of information.
That was lower than I expected. For some reason, I thought it would be closer to 50%. You have done some very interesting experiments. One that I was reading about is you attach like GoPro cameras to people, and then you were able to see what they remember. Can you share what was that experiment and some of the learnings of it?
Yeah, absolutely. So a lot of the studies in cognitive psychology and memory have been basically done in laboratory conditions. So, for example, I give you a list of words, and later on I ask you which words do you remember, or I give you a list of pictures and so on. So we wanted to get real life data on what people remember and when and how. So we did a series of experiments where people were walking around with a GoPro camera, and therefore we had ground truth about exactly what they observed. So that way we could ask in a real world scenario what they remember. So in one of the experiments, for example, people had to traverse a particular route within the Boston Museum of Fine Arts. So we told them, go to this room, then go to that room, and so on. And then we had continuous monitoring of the video and audio surroundings. And therefore, later on, we brought people back 1 week later or 1 month later, even a year later. And we asked very specific questions about what they remembered from that experience. So, for example, you may run across a particular person. Do you remember that person, what they were wearing, and so on? Did you see a particular painting from this angle or that angle? So by being able to collect this kind of data, we had ground truth information. And so this helped us build machine learning models to be able to predict what people will or will not remember. The short story is that people remember very, very little of their experiences. So only a tiny fraction is crystallized in the form of memories. The majority of our visual and auditory experience is completely is very hard to retrieve.
And as you build those predictive models, what are 1 or 3 key elements that you found that has like high correlation in like what people were seeing and what they remembered?
So we spent a lot of time doing a combination of computer vision annotations and manual human annotations of the content of the information they were encoding. One of the variables that we spend a lot of time annotating is the emotional valence of different events. And that was one of the best predictors of memory, basically. Events that have no emotional valence are much harder to remember. And perhaps intuitively, events that are particularly emotional, either happy, sad, interesting, engaging, those are events that are more memorable. So we had a way of quantifying these and therefore show with machine learning that emotional valence is one of the key predictors for episodic memory crystallization and consolidation.
And that emotional valence, I'm curious how much it varies. Like, are there commonalities across what sparks an emotional element for me than what sparks an emotional element for you? As, like, for example, we walk on the same places?
Yeah, so we did another experiment where we showed people movies, for example, and therefore for a movie, we annotated both the emotions rendered by the characters in the movie, as well as the emotions experienced by the viewer. So in that case, there were pretty strong commonalities in how people experience emotions during the movie. People were happy, sad at similar moments, and so on. But in the real world scenario, as you pointed out, there's much more variation. A particular event may be highly emotional for me and may do nothing to you and vice versa. So that's one of the challenges with studying emotions, predicting emotions, and then using that for memory encoding, because it's so personal, so individual in a way, and And you're absolutely right that there's a lot of heterogeneity across people in how we experience different events.
You argue we can learn a lot about AI by studying the brains. And as we now build AI memory systems, should the goal be to replicate how the human brain mechanism around memory work? Or should it be an inspiration for kind of entirely new designs on how memory is? And an alternative way of framing this is, what aspects of human memory do you think are limitations that we should not be applying now that you're building AI memory?
My general sense is that the goal is not replication, but rather inspiration, as you said. So there may be a lot of biological constraints that are of less interest for us in terms of AI and building systems. Capacity limitations, for example, that are basically almost non-existent for AI systems in many ways. And yet, on the other hand, one of the big challenges in AI is to be able to retrieve relevant information that we need at any given moment. So it's easy right now for us to basically store our entire lives. So if we wanted to, we could have a camera on a baby since the day they are born and then record absolutely everything. So hard drive space is pretty cheap. It's not inconceivable that we will have lots of humans in the near future where you have absolutely everything being recorded. But that's pretty useless in a way. So just storing the information is only a very simple first step. The key magic of memory is being able to spontaneously recall information whenever you need it. And that's a much harder problem. So if you think that you have a few terabytes or petabytes or even more of data, at any given moment, you may only need a tiny fraction of that. And how do you actually find that? So in computer science, it's easy to find things by date or by using specific keywords, but this is just not how our memory works. So we bring contextually relevant information from our memories, and that's the part that's particularly challenging.
And the approach I've seen the current memory systems that have been developed is a lot around, let's use retrieval augmented generation of vector search and combine now with a bit of hybrid search with keyword matching and take it with a more like data approach perspective. What are your thoughts on the current approaches to do that retrieval that, as you mentioned, is really the key challenge in this space? And what are the current approaches getting right or getting wrong?
Yeah, so I think RAG-based approaches, for example, are a good initial step, but they fall short of what we can do with human memory. One example is the fact that we often retrieve memories that are based on associations that cannot be found easily by RAG based on certain kinds of encodings or embeddings. Because of these associations, also, our brains very quickly and effortlessly jump from one memory to another. And again, that's hard to emulate with RAG-based approaches. And perhaps the biggest challenge with RAG is that to begin using RAG, you need to find those keywords. You need to start using some prompt or search terms. And our memory basically works without search, without prompts. So if I tell you about the Red Sox game in baseball, your brain may sort of fire lots of memories around that without you having to sort of type or search for specific keywords or for specific events. So basically, we think that memory is very different from search, and RAG is kind of sort of ingrained in this notion of searching for information.
One part that you were mentioning is humans have a lot of the parts that we remember tend to have some emotional connection to that specific memory. As you think of AI, you think that emotion part would play a role into how we design AI memory systems, or that emotional part is one of those that it's more like that's how human memory works, but as we build AI memory systems, that emotion is not necessarily relevant or useful.
I think eventually we want to get there. Part of the challenge with emotions is that it's very hard to build data sets for annotation and then training and so on. So I think eventually we will want to include aspects of emotions in memory storage and memory retrieval. Right now, that's extremely hard. So it's easy to record basically videos and audio and record our Zoom meetings. We can do all of that basically effortlessly now. There are lots of tape recorders to record meetings in the real world as well. But actually attaching emotions in real time to those events, that's extremely hard and costly to annotate. So eventually, yes, we want to get there. I think that that's not going to happen anytime soon.
As you think even about inside Memorious about building those AI systems, how do you think about creating a similar compression policy without necessarily doing some hard coding that generalizes well in the way that we compress data?
So what we're doing is taking data and then using our models, predicting what people do and do not remember, to try to build that type of compression. And then through our retrieval algorithms that we call ambient intelligence, we take into account the ambience, the context, which includes where you are, with whom, when, and as well as the content of the email you're writing or the conversation you're having. And so all of that is part of the ambience, and we use that for retrieval. And once we retrieve a lot of memories, another critical aspect is to rank those memories. So in the same way that you may search for a website and there may be thousands, if not millions of links, there may be thousands of or millions of memories. And part of what we do in our ranking algorithm is to figure out which one is the most relevant to you right now. We cannot provide you with a million memories. That's not useful. We want to bring up the D1 or 2 or 3 potentially memories that are most relevant to you right now.
And so there are currently existing re-ranker mechanisms that exist out there. What do you think they are still not getting? Again, as I've tested the different systems today, they have not been able to surface necessarily with a high accuracy the right information high. What are these re-rankers getting wrong? Or like, how are you approaching those re-rankers in a different way?
So our approach is strictly human-centric. So our models are based on our studies of what people do and do not remember. So this is different than ranking information based on pure metrics like saliency or entropy and so on. So our models are strictly based on our current understanding of what people remember or not. And then on top of that, what we do is to personalize this type of ranking. So we have general models that rank memories. And then on top of that, the user can further personalize what they find relevant or not. And then we can use things like RLHF, reinforcement learning with human feedback, where basically humans are swiping right if a memory is relevant, swiping left if it isn't. And then we can use that in a reinforcement learning fashion to further personalize the system.
Now that part makes sense. Another relevant portion as I think about memory is forgetting. As far as I understand, forgetting is a core part of how human memory works. And if you were to design a forgetting schedule for AI memory, kind of what signals would drive that decay or refresh, and how will you ensure that the system retains the relevant information and really discards that relevant information? Or do you think that that discarding part of the forgetting some data is not as relevant as we think on AI system memory?
I think it's somewhat less relevant. Again, hard drive space is almost free these days. So I think we need to worry less about forgetting and more about how to bring value. I also want to make a clarification. Most of us talk about forgetting all the time. So I forgot this, I forgot that. In reality, in many cases, we don't truly forget that information. It's there in our brains and we just cannot retrieve it. So let me try an example. So let's say I ask you, what's the name of your second grade teacher? Perhaps you don't remember. Perhaps it's very hard for you to get that information. But now if I ask you, was it Jennifer or was it Susan? And then maybe immediately you would say, oh, of course it was Jennifer. So what that shows is that the information is still there in your brain, but you're struggling to actually retrieve the information. It's not truly forgetting. So like that, I think that there are many examples of information that really disappears, that it's completely gone. Okay, so if you think about every pixel in an image, that's really gone. That's really for forgetting. But there's a lot of other information. In fact, I would argue most of the information that we encounter is not truly forgotten. It's still stored in the brain, but we cannot easily retrieve that. And that's where AI can really help.
Now that was an amazing example to bring it home. And I was speaking with your co-founder Stan then, who told me that you had co-discovered the concept known as the Jennifer Aniston neuron or the grand model cell, and that it was one of the first models of how the brain represents and retrieve memory of abstract concepts. Can we share more about this and the implication that it has on understanding memory?
So this was work that we did in collaboration with neurosurgeons, in particular neurosurgeon Itzhak Fried. And that work entailed recording the activity of neurons in the human brain invasively. The neurosurgeon implants electrodes inside the brain in order to record neuronal activity. These are patients with pharmacologically resilient epilepsy, which means that current drugs cannot treat their seizures. Surgeons put electrodes to map where their seizures are coming from in order to resect that tissue, to remove that part of the brain that's responsible for the seizures. The patients typically stay in the hospital for 1 week, and during this 1 week, we have an unprecedented opportunity to scrutinize the activity of individual neurons at the highest possible spatial and temporal resolution. So in that particular experiment, we were showing pictures of faces, houses, people, objects, etc., etc. And what we found was a remarkably a strong degree of selectivity and invariance in the neuronal representation in a part of the brain that's the hippocampus and the medial temporal lobe. We know that these areas are relevant for memory formation because if you remove the hippocampus in humans on both sides of the brain, then people cannot consolidate memories. Then people are perfectly normal over the course of 5 minutes. You can have a conversation. They're super intelligent. But then if you ask them the next day what that conversation was about, they don't remember anything. So if you think about movie Finding Nemo, there's a character Dory that has short-term memory. Basically, she's navigating perfectly fine, but then 5 minutes later, she completely forgets everything. So we know that we are in the part of the brain that's relevant for memory. And these neurons were representing information, like, for example, the famous actress Jennifer Aniston, in a very specific way. So this neuron would be turned on upon showing pictures of Jennifer Aniston, but not upon showing pictures of other actresses, other actors, etc., etc. So that pointed to a very specific and sparse and invariant representation of information at the very heart of the memory system in the human brain.
And speaking of memory consolidation, my understanding is part of how humans consolidate those memories happens while you sleep. First, that may be right or wrong, so that would be the first answer. But secondly, should AI memory also, as you think about building an AI memory system, do you think there is a need to create that space for memory consolidation, as seeing every so often?
So memory consolidation does happen during sleep, but not exclusively during sleep. So I think there's memory consolidation both during sleep and also during the awake time. In the past, before the AI revolution, in some sense, people developed neural networks with wake-sleep cycles, basically, where you would have some time where you would basically replay or learn information. That's somewhat less prevalent now. I think sleep is quite complex, and it's probably arose through evolution due to a combination of different things, including staying safe during the night and so on. And evolution probably co-opted sleep for things like memory consolidation. It's less obvious to me that we need to implement that in AI. I think that in AI, this is one of the things that we don't need to replicate biology. We can sort of step away from these basic aspects of biology and do memory consolidation without the need for wake-sleep cycles.
And one of the things that we were speaking last week that I found super interesting was this concept of infinite memory. Can you share for the audience what you mean by that and why it could potentially eliminate the need for search and prompts, and how close or not are we to making this a reality?
So what we mean by infinite memory is the ability to essentially retrieve your entire life. So everything that's digital, in principle, we should be able to access it. There's no reason why in 2025 we should forget anything and we should not have access to our entire digital persona. That's what we mean by infinite. The main challenge is to really say infinite is for old folks like me, for example. I lived in an era with no internet, believe it or not. So before I was 20, I didn't have access. So everything that happened before I was 20, only a very tiny fraction of that is digitized. So if we step aside from that, I think that as we get even more than we are now into having everything digital, we should have access to basically infinite memory, modulo, things that are not in digital format, basically. So once we have that, then the main issue is about retrieval. And what we're building is a system that works like human memory, where you don't need to search information. We call it omniscient AI, basically. So the AI knows what you need. One of the reasons we search for things is because we forget. So sometimes we search for things because we want to get access to information we never knew. Okay, so if I asked you, what's the capital of Cambodia? Maybe you never knew that information. That's not quite memory. But oftentimes what we're searching for are things we know and we forgot in a way. So if we could have access to infinite memory, we would essentially render prompting and searching obsolete.
And this might be going to a whole rabbit hole, but you were mentioning infinite memory, like if the concept of if we could start recording everything we did in our day to day, we will have in the future, hopefully, and through Memorious, a way that you're able to have access to those data. What are your perspective in that hurdle around people having now from now on record like everything that happens in their day to day life? And I currently or recently bought like a limitless pendant, which is like something that you wear, and the amount of controversy that it has generated among people is pretty high. But do you think like it is a temporal thing that in 5 years, it would be normal for everybody to be recording everything they do in their daily lives, and it's more of a timing question? Or what perspective do you have on that kind of social adoption of like really recording everything you do in your day-to-day life, especially as technology is getting to the point where that is feasible?
Yeah, these are great questions. I don't have strong opinions. I think in the work setting, people are getting more and more used to recording almost everything. Now we have lots of Zoom meetings where we have recordings of Zoom meetings. So I think that that's becoming very, very prevalent. In a social setting, of course, first of all, one should emphasize that it's an issue of consent, and that's crucial, of course, for any future of recording. So I think that there may be many situations where people will be perfectly comfortable with recording information, and many situations where people may not be comfortable, at least in the near future, with recording information. So if you go out with friends to have a beer on Friday night, maybe that's not something that you want to record. But if you're having TA session with students where you're explaining a particular problem set, why not record that so that everybody can have access to that information later on? So I think it's more nuanced, and it will depend on the particular situation how much we will be able to record real life information.
But going back to designing memory systems, one of the challenges I've seen is how you design systems at scales. For example, over like defining or building a memory system with a small sample of data might be easier, but as the data starts to scale, it's become messy. And one example of this is you start seeing contradictory data. So let's say I used to like Italian food like a year ago, but for different reasons, I don't like it anymore. And currently my favorite food is Asian cuisine. Like how, as we build memory systems in AI and you start scaling it and starts encountering those issues like contradictory data, how do you build either, I don't know if it's policies that really understand what's the appropriate, in that case, like overriding old data with new data process?
Yeah, I think that's also a very interesting question. In general, memories are dynamic entities that change over time. Even in the extreme case of things that we think are completely crystallized and don't change, that's mostly an illusion. Every time we retrieve information, we're probably retelling ourselves the story, and we're changing the story a little bit. So even things that we firmly believe, that's exactly how it happened. And oftentimes it happens, you're talking to your spouse or to somebody else, and it was the same event and you have different recollections. So sometimes we perceive things differently, but also sometimes we just change the story as we narrate it further and further. And other times people change. We can change our views. We can change. You said, I love Italian food. I hate Italian food. So people change over time. And so we need to be able to encode memories as dynamic entities that can evolve over time and can express that level of complexity where growing up I did not like coffee and now I cannot live without coffee, or any other change over time. And I want to remember the before and after of that transformation.
And do you think that process would also be tuned as a result of reinforcement learning? And
So we think that reinforcement learning will play a strong role in personalizing information, in figuring out what kind of information every person needs or wants to retrieve at any given time. In terms of changes over time, we think that it's part of the core encoding of memories that we need to incorporate a time variable and then allow to associate memories over time and understand that that a particular event is part of the same memory, but it has changed from one time to another.
we're starting to see an emergence in the AI space on what some people are calling it the memory stack or the context management stack. Do you expect that memory stacks will start to fragment by modality? So let's say one provider of more text dominant modality, other more like visual first or either audio first providers? Or do you think that it will consolidate and the way that to build a memory system would be agnostic in terms of modality?
So first, I think that what people call context in memory is somewhat different from the way we understand and we process memories. For example, a lot of large language models now are racing to use ever larger context. Even the largest context that people can imagine with large language models, they still fall orders of magnitude short with respect to memory. So what we really want is, my entire 20, 30, 40 years of life history. And there's no way that in the foreseeable future that will be part of the context window. In terms of the modality, I think it may depend on the application. For the kinds of things that we are envisioning where we want to augment human cognition, we don't really have memories separated by modality. So we want all of them to be together, whether it's a visual memory, an auditory memory, a text. In fact, it is often the combination of who said what and when and how. So it's a combination of the visual and the language content that's critical for us in terms of storing memories. But there could be applications of memory that are purely text-based, or maybe they're applications that are also purely memory-based, as in retrieving videos, retrieving pictures, or in some cases only retrieving textual information. But in general, I think of memory as one monolithic thing that we want to conquer invariant fashion.
And back there, you were mentioning the foundational model players beyond them expanding the context windows, which, as you said, is a different thing. We have seen OpenAI, especially, and I think Anthropic as well, getting or hinting their intentions of going deeper on memory. And even they released earlier this year, like ChatGPT memories. And now you're able to ask some questions about your old chats. What role do you think this foundational labs, OpenAI, Anthropic, will have in the memory space?
I'm super excited by what OpenAI is doing in terms of memories. I still think that, first of all, they're kind of stuck in this search and prompt mode, which I think is very, very useful. But we need to go beyond that eventually in terms of the interface for memory. And the second distinction is that a lot of these efforts are still based on tag and embeddings, and I think that human memories have a radically different encoding format than what we're using right now. But that said, I think it's super useful. It's very nice to be able to open a large language model and then be able to ask a question that relates to something I asked a week ago. And so I think that that's going to be super useful.
And the other thing on the ecosystem that I'm starting to see an emergence is benchmarks for testing different memory systems. What's your opinion on the current benchmarks that exist out there, and how do you think it's a good way to build like a good benchmark system for memory?
Yeah, so that's a very very interesting question, because benchmarks have been so important to propel different fields within AI, and it's been very hard to come up with good benchmarks in memory. We're building our own benchmarks that are human-centric, that are based on human memory and what people remember or not. So I think ultimately for any human-centric application, these are going to be the best benchmarks, but those are somewhat slower and smaller scale than what can be built, let's say, in images or other domains, because ultimately we need to ask people what they remember and what they don't. So I think it's easy to build systems that are less human-centric, where you generate information and then you test AIs in terms of how well they can or cannot retrieve different forms of information. I've seen many benchmarks of that flavor, and I think those are very useful. But ultimately, especially in the context of augmenting human cognition, we really need human-centric benchmarks, and that's been quite sparse in the community.
No, I agree with that portion. And related to empowering the end user, there's been some debate in the past couple months around who owns the memory now with AI. And what I mean by this is there's been a camp that's arguing that end users should own and have like a portable memory system where I use like ChatGPT and I interact. There is some information about me that's stored there that should be captured in a memory system that I should be able to move to Anthropic, or as I use even corporate systems, Salesforce or others, have that one element where I, as a user, own it. What's your perspective on that? Me as a user having both the right and the feasibility, given the different market dynamics of the user really owning their memory or not?
I really like that idea, and I would definitely support it and embrace it. Technical issue is that about formatting. For example, the way we are encoding memories is very different from the way OpenAI is thinking about memories. For things to be portable, there has to be some sort of a consensus of what that format looks like. So right now, I think it's a little bit challenging to achieve that. So I really like the idea in principle. I think people should own their memories and they should be able to move them from one system to another. All these systems should be able to talk to each other. We think that we have a better way of encoding memories that's human-centric, but others would have to adopt that to be able to use that exact same format. So there are questions about formatting, basically, but once we solve that, I think one should be able to have portable memories that you can drive through different systems.
Yeah, and the other part that will be interesting to see is the incentive system beyond like the feasibility, and hopefully memory is able to do it and then gain that adoption. But the incentives of the different players, if they will be open and hopefully they go that direction, history has shown can be hard to get them there. But we'll see.
Absolutely, yeah.
And you also mentioned in our past conversation research on how AI memory can help people with memory loss. I was curious to get your thoughts on how these new technologies might support patients with, for example, conditions like Alzheimer's or short-term memory loss.
Yeah, so Alzheimer's is a degenerative condition. So there's a huge progression from at the beginning, people starting to suffer from memory loss all the way towards the end, where it's very hard to even interact with people with Alzheimer's. My grandmother passed away because she had Alzheimer's, so I witnessed the deterioration in her memory capacities. We all forget things. A 5-year-old, a 10-year-old, a 20-year-old. It's just that this gets accentuated as we age, and in particular for people with Alzheimer's. So especially at the onset of a disease like Alzheimer's, when people are starting to forget things, I think Memorious can be transformative in helping people in their daily life. So they can help them remember, did I take my medication, yes or no? What did I eat for lunch yesterday? What was my grandson's name? What are the names of their best friends? What is the movie that we watched together 2 weeks ago? And why is it that my granddaughter was scared of that shark in that movie or something? So I think these are all things that people struggle to remember. And again, there's no reason why we shouldn't be able to bring all of that information to people with Alzheimer's. This is not a cure for memory problems. This is an aid, an enhancement to their memory so that they can enhance the quality of life. Because of their memory problems, people with Alzheimer's end up sort of exacerbating their own condition because they tend to isolate themselves and so on. So I think this can play a transformative role, even though it's not curing Alzheimer's, it's just helping people with memory loss.
No, but that's one exciting area that hopefully we get there. And as you've been working on building that, translating all your years of research into Memorious product platform, what has been like, if you had to pick one of like the biggest technical challenge or bottleneck so far, what has it been?
Well, I think there's several things, but one of them is ensuring that we can rank memories, figuring out of all the possible memories, what are the most relevant to people right now. So because this is not just a question of memory, but it's the side where we need to rank memories and figure out what brings value to people at any given moment. So that's on the technical side. And then we're pretty early right now in terms of adoption, but I think that it will also be exciting to interact with market forces and see what people are interested in and how people adopt different aspects of Memorious.
And other area that goes outside of memory, but I was curious to get your perspective. I was reading, and you also touched during your research years a little bit about consciousness. And in simple terms, what is your current working definition of what consciousness is? And do you believe that by building a sufficiently advanced AI memory system can lead to AI developing some degree of consciousness or not?
Yeah, that's a question that's been hotly debated in many circles these days. I think it's very hard. One of the challenges has been that it's been very hard to come up with a Turing test for consciousness. So you're probably familiar with the Turing test. Is this an AI or a machine? But now if I ask you, is this system conscious or not? It's been very hard to assess that. So Francis Crick, who did a lot of work in consciousness and inspired a lot of researchers in consciousness, said that early on in research, we should not get stuck with the definition. We all have a sense of what it means to be conscious, the difference between being awake, being asleep, being alive, being dead, when you're conscious, when you're not. We think that many animals also share consciousness, if perhaps all animals also express consciousness. Perhaps right now the best technical definition is a theory called integrated information theory, IIT, championed by Giulio Tononi and Christoph Koch. It's a controversial theory, but it's the best mathematical formulation of how one could define in a system whether it's conscious or not. So to the extent that one buys into IIT, that provides a way of assessing a neural network, for example, and how much sentience there is, how much it is conscious or not. So my personal view, share with Christoph Koch, is that intelligence and consciousness are largely orthogonal. That is, we can advance and build systems that are extremely intelligent without having consciousness, and vice versa. There could be systems that are very high in terms of consciousness, but they're not intelligent at all. So these are largely independent, although in practice there may be correlation in the biological kingdom. In principle, one could build super sophisticated large language models that get that beat gold Olympic champions in the math Olympics and so on, and that can do discoveries and that they can write poetry and so on. And that doesn't mean that they have developed any kind of consciousness. But again, all of this is highly controversial. Lots of people disagree with what I'm saying.
And this goes more on the general advice area that I also have to ask, which is, having studied memory for so many years, what's one advice you give people into how to remember things better? I recall reading a book, for example, an exercise that they recommend. I don't know if you heard it and if it's useful or not, around imagining a house and placing like a name in each room, something like that you advise the audience on if they want to develop better memory.
Yeah, so that's called the memory palace method. It's a very old method developed by famous speakers like Cicero to be able to remember a whole speech, for example. So that has proven quite useful for a lot of people. I'm not one of them. I've never actually used it. You may know that there are memory tournaments where people, for example, shuffle a deck of cards and they try to remember the order of every card, and people have amazing accomplishments in that front. In general, what I tell students when I'm teaching a class is that the best way to remember things is to understand what's going on. So not trying to memorize things by heart, but actually understand it. So if you understand an equation and where it comes from, then you don't have to memorize every item, and that helps you remember the logic of what's going on. So I think as a general rule, being cognizant about what you're doing and understanding what you're doing and being all in any given activity is very helpful in terms of forming memories. But yes, if you want to remember the name of every student in a class with 300 students, that's challenging, and things like the memory palace can be very useful.
Oh, that's useful. And the other part is, so you've done a big shift now, going from 18 years in academia and research to now becoming a founder. What's been the hardest part of that transition, and what advice would you give to other people who may be in a similar position to you, that have like this extensive research experience and are curious maybe about the startup world and starting something, but hesitant on that front?
I think it's a very, very exciting adventure. It's a different world in many ways. And so my advice is first not to be afraid and to embark in the adventure, which I think is quite exciting. But then also, one of the things I learned along the way is that we need to take as much help as we possibly can from all of our friends and colleagues. So I've learned so much by just talking to people. So we got a lot of brilliant advice from people in the business school, from venture capitalists that we talk to, from experts in marketing, from experts in all kinds of other domains, people that I had not basically interacted with as much in my very specific academic field. So there's so much talent out there and so many amazing people that are willing to talk and help, and one should capitalize on that as much as possible.
Yeah, no, I agree on leveraging experience of others in those areas that may be newer to you. And to close by, I would like to do a quick fire round. So it's like 3 quick questions and you give me your immediate reactions.
All right.
If you had to pick one misconception that non-experts have about memory, what it would be?
I think it would be about forgetting. I think we talk colloquially about forgetting, and most of the time we don't really forget. The information is there and we cannot retrieve it.
What's the one thing that you change your mind about the AI space in the last 2 years?
Without a doubt, large language models. If somebody had asked me a long time ago, I would have never predicted that they would work as amazingly well as they do. It looks like magic.
During the next 5 years, do you think we will be able to create a digital twin that replicates, say, with a 85% accuracy, a person? If I have I create a twin of myself and then you have a conversation with it, likely it's 85% what I would speak and answer and ask to you.
Yes, I would bet a lot of money that we will be able to do that. Not in terms of the physical aspect in the 3D world, but in terms of you ask me a question and you have to figure out, was this my answer or my twin's answer? I think you won't be able to distinguish it the majority of the time.
And I know that last week you gave me a good recommendation of movies that relate to memory. If you can give the audience that are maybe after this episode curious to just be embarked in the memory journey, 2 or 4 movies that you like that relate to memory.
There are many memories. There are many movies that have dealt with memory loss, like 50 First Dates and Memento, even Finding Nemo I mentioned earlier. There's a sci-fi. There are many sci-fi movies as well. So, you mentioned Black Mirror. There's an episode or 2 episodes that deal with memory. There's a series called Altered Carbon, where basically you can implant memories from one person into another. I think the possibilities are so exciting and endless in the science fiction world.
And I didn't add this one on the list, but given that you mentioned implanting, what are your thoughts on the neural link implants?
I think it's super exciting. I think that many decades from now, we will be able to extract memories and implant. Right now, we're still very, very far. But I think it's super exciting what Neuralink and many other people are doing in terms of invasively understanding brain function.
And to close one more deeply than the others, what would you say are you personally optimizing for in life?
My goal is to actually make the world a better place. So I sincerely hope that by building a system that can bring perfect and infinite memories, we will be augmenting human cognition and make lives better.
No, Gabriel, I highly enjoyed this conversation. Thank you for joining me.
Thank you very much.